Welcome back, chemistry fans. Today, what we are going to do is our warm up number 22. And so, what we're going to try and review is some of the naming routines we've been working on recently. So, let's jump right into it. Let me share my screen with you so you can see what we're working on. Boom, boom, boom. All right, so here we go on this one. We are going to first start off with a polyatomic ion. So you're saying, what in the world? I don't polyatomic ions. There was a list that you were provided in your cheat sheets, and it has all of these multiple names. How do you know if you have a polyatomic? Well, one of two different things has to happen. One, there has to be more than two atoms. Anytime there's two atoms, it ends with IDE. If it has more than two, or it has these parentheses, that tells you you need to go and start looking on your list to find out, matching up, what is the name. NO3 has the name nitrate. Now, it doesn't matter that there are three oxygens. That's the name of nitrate. It doesn't matter that there are two of the nitrates. That's because the charge of barium is +2. The charge of nitrate is -1. They crisscross applesauce. So the name of this one is barium nitrate. Okay, now the next one, notice what it has. It has a Roman numeral of 3. That means that niobium, and that's NB, I believe. Niobium, NB is, yeah, NB is the symbol, and it has a charge of +3. And sulfur, we need to find out what the charge is. It doesn't mean that there are 3 sulfur, the charge is 3. It means that you need to look it up. Now, coincidentally, after you crisscross, it is going to be that there are 3 sulfurs, but you can't get the correct answer unless you put this charge of the sulfur up here. So after it crisscrosses, it's going to have NB2S3 as your final answer. What is the name of this one? Neither of these have Roman numerals. Neither of these have more than 2 atoms or 2 elements. So yes, there are 3 atoms, but it's not that determines the name. It's binary, 2 different elements. So we write the first one, sodium, and you write the second one, selenium, it becomes selenide, IDE, with the suffix because it's binary. Same thing here. Now, this is binary. However, chromium is in the middle of the periodic table. So to figure out what the charge is, what the Roman numeral is, we have to do the Wonder Woman move, and we have to cross backwards. So that 3 comes up, and it means that the charge of chromium is 3. So this becomes, this becomes chromium, Roman numeral 3, oxide. It ends with IDE because it is a polyatomic. You should put parentheses around your charge. Now, the next one, this is carbon 8. ATE tells you it is polyatomic. So you need to go and look on your chart, and you find out that carbon 8 has a charge of -2. It has a formula of CO2. Aluminum on your periodic table will have a charge of +3. We take those 2 charges, we crisscross them down, and we end up with our final answer of Al2 parentheses CO3 3. Now, if you do not put parentheses, all you would be saying in this answer is that there are CO33. That's not correct. Or you might misinterpret it and say, oh, there's already a 3, so I don't need to write it. No, that was the formula before we even crisscross. So you must always still crisscross. And the final one, magnesium iodide, IDE, tells you it is binary, so it's just iodine. We go and look up their charges, +2, -1. Magnesium is not a transition metal, so we won't need a Roman numeral. We just crisscross applesauce, and we end up with our final answer, Mg1I2. Now, you don't need to write the 1, so this is our final answer. All right, this is everything that I hope that you have started to review. Today, we pick up one more. It's called the covalent bonds. Thank you very much. I will talk with you again just in a second with that lesson. Bye-bye.